Hello everyone, welcome to M112 Linear Algebra, and in this video, I will answer exercises 2.3 item 53, and I am Geraldine B. Rufino from Math 2A. In item 53, prove that if A is invertible and AB is equal to 0, then B is equal to 0. We prove this using the following properties, according to the Book of Elementary Linear Algebra, 6th edition, by Larson Edwards Falbo. According to the Theorem 2.7, uniqueness of an invertible matrix, if A is an invertible matrix, then its inverse is unique. The inverse of A is denoted A raised to negative 1. A multiplied by A inverse is equal to I, or also equal to A inverse multiplied by A. Next is, according to the Theorem 2.2, properties of zero matrix, if A is an m by n matrix and C is A scalar, then this is true. If C multiplied by A is equal to 0, then C is equal to 0 or A is equal to 0. Or multiplicative property of 0, if A is an m by n matrix and 0 is m by n zero matrix, then 0 multiplied by A is equal to 0, or A multiplied by 0 is equal to 0. The next is, according to the Theorem 2.4, properties of the identity matrix, if A is a matrix of size m by n, then the following are true. Number 1, A multiplied by identity matrix is equal to A. Number 2, identity matrix multiplied by A is equal to A. Using the three properties and condition, A multiplied by A inverse is equal to I, or also equal to A inverse multiplied by A. 0 multiplied by A is equal to 0, or A multiplied by 0 is equal to 0. And A multiplied by I is equal to A, or I multiplied by A is equal to A. We can prove that if A is invertible and AB is equal to 0, then B is equal to 0. Because we have a given A is invertible, so that A inverse exists, which means that A inverse multiplied by A is equal to A multiplied by A inverse, which is equal to I, or the identity matrix, which is also in this property. Because A is invertible, we can multiply both sides by A inverse. So A inverse multiplied by AB is equal to 0 multiplied by A inverse. In A inverse multiplied by A, applying the associative property, we can group the A inverse and A, which will become a quantity of A inverse multiplied by A, which is multiplied by B, is equal to, in 0 multiplied by A inverse, applying this property, 0 multiplied by A inverse is equal to 0. Next is, in A inverse multiplied by A, applying this property, A inverse multiplied by A will become, or equal to, I, which will become I multiplied by B is equal to 0. Next is, in I multiplied by B, applying this property, I multiplied by B will become only B, which is equal to 0. And that's what we want to prove, that if A is invertible and AB is equal to 0, then B is equal to 0. And again, I'm Geraldine B. Rufino from Math 2A. Thank you.